Hey, you Evans, thanks for coming, guys. It's nice to see you all saying hi on the chat. It's good to see you. Just want to make sure that hoodies ain't fashion, Marnie. Oh, that's funny. And then Ryan does a sad face. Very weird. Good to see you. Just want to make sure that hoodies ain't... Do you know what? It's such an echo in here. It's the room itself, I think. It's not really my fault. Right. I've got a new cam, guys, so I'm going to... I'm just gonna change things up. Boom! Way! Got a new webcam. So this means that I can still have my face. We want to zoom in. Zoom. Right, let's share screen. I can keep myself there now. So when I'm doing some dancing around, you know, that I always do. Share screen. Let's go for that one. And then I'll close down my YouTube feed because I've got that up and that just seems to be working okay. And I've got my chat. There you go. I can see you guys all in the chat. Mr. Duncan rocking the chain. Yeah, I always wear this. Wow, professional stream. This is really clear. E-boy, Mr. Duncan. I don't really know what an e-boy is, but I don't think I like the sound of it. Yes, bro. E-boy, Mr. Dunks. I'm going to stop now. That was terrible. I take that back. I didn't do that. Delete. Okay. Right. Hide. And then on to here. Right. Okay, guys, you guys are 11A. So today's lesson, I'm just nice reggae. Nice. Chem classes on Twitch. Saying it makes no sense to me. Right. So you guys should still be able to see me and then be able to see my screen too. So we're just doing today, I just want to do a little bit of revision. I know that your mocks are coming up. So I want to do some iGCSE. Got my little fan there. iGCSE. This is paper 1 for those people doing dual award. This still works. Yeah, paper 1, organic revision. Organic rev. Okay, so not many learning objectives, to be fair. There were just key things I want to make sure I do. Know the steps. Steps in fractional distillation. You can make notes of the learning objective. Distillation. It's French for distillation. Next one is be able to draw isomers. We've done quite a bit of that over the last few lessons before the breakup, but it's nice to do it a couple more and do a bit of naming as well. And then what I'm also going to do is I want to actually look at some exam questions. So I've got some exam questions up, some exam cues specifically, so you can see how my lesson relates to those. Okay. I'm also going to create a list of some keywords as well that you definitely need to put into your vocabulary, just as reminders. So let's do some vocab first of all. Vocab for organic. Now we did this, just to let you know that we did this. I need RGB LEDs. Thanks, Libby, for that. That was really useful. We started GCSE in year 9 and we covered the parts of organic from that in that year. So it's been a long time since we last looked at it. I know that we've been doing naming and drawing over the last few lessons, but I do just want to focus on these particular questions that come up. And vocab is very important for organic. So bullet point number 1, vocab number 1, hydrocarbon. Yeah, hydrocarbon. Now, I'd like you guys, so pause the video, write your definition, and then you can unpause and mark it. A compound, usually one of the bits that's often forgotten, a compound made from hydrogen and carbon, and this is another keyword, only. So, examples of hydrocarbons. Ethane, we know this is a hydrocarbon because the only atoms in it are hydrogens and carbons. So this is classed as a hydrocarbon. Non-hydrocarbons, ethanol. Yeah, our Friday night molecule. You guys, of course, have never even tasted or even smelled this stuff. Yeah. Yeah. Helping. Excuse me, cough there. So this is the ethanol. This is ethanol. This, by the way, is ethane. Ethane. So this is a hydrocarbon. Hydrocarbon, yes. Yeah. this is not a hydrocarbon. And of course, the reason being is it contains oxygen as well. Yeah, not complicated, but they've done this many times. They like giving these examples and show. He's just red, green, Russian water. Yes, yes, Russian water, Amani. That is absolutely right. Yeah, that's what I have in my flask at work, Russian water. So hydrocarbon. Next vocab. Let's go for alkane. Yeah. A compound containing only carbon and hydrogen and only carbon-carbon single bonds. That's important. Carbon single bonds. Just see signal bonds? No, that is single bonds. Do you see what I've done, guys? Check, look. Carbon single. Look at that. Look, it's there. Look, I just highlight it. It's amazing. It's a carbon. Yeah. A tad concerning. Yeah, sure. Next, we can go molecular formula. Molecular formulae. The actual, notice my capitalization, the actual number of atoms of each element in a compound. Example. Yeah, example. Let's go for, I don't know, C6H, I don't know, H12Cl2. So this is a molecular formula. It tells us that there are actually 6 carbons. There is actually 12 hydrogens, 6 carbons, 12 H's, and 2 Cl's. Yeah, the actual number. That, of course, then rolls immediately into empirical formulae. The simplest whole number ratio of atoms of each element in a compound. Example. I know it seems odd me doing these kind of definitions in here because some students often say, why is it that molecular and empirical seem to appear in organics so heavily? The reason being is because of the way that organics builds in terms of following things like bond rules. What you tend to find is it's very easy to link molecular formula and empirical formula within an organics context. So I chose this one up here. This was my choice. And it's really easy for me to be able to now simplify that to a whole number ratio. I simply divide it by 2. I get whoever it is that's closest to 1. So in this case, the person who's closest to 1 is chlorine. So I'm going to divide everybody by that number. Yeah, because I get chlorine to 1, the simplest whole number ratio. You cannot have fractions in empirical. Yeah, so if I want to now do the empirical of my compound above, I'm going to divide everyone by 2, which would be C3H6Cl. That is the simplest whole number ratio. This one here, these two are linked together. Yeah, so this one here is the molecular, and this one here is the empirical. Yeah, it's a very easy setting to do it with. It then, of course, immediately then drops into displayed, of course, but displayed does have a definition, a pictorial diagram showing all atoms and bonds. Dichlorohexane. Oh, Tiff, very impressed. Well done. Tiff, obviously, though, you're going to give me numbers, right? It could be 1, 1, 1, 2, 2, 2, 1, 3, 2, 3. Let's see where I'm going with this. There are loads of different versions of that. I can't, right? No, you can't. Oh, Tiff, you didn't draw it. Absolutely right, Tiff. That's why molecular, like empirical, sucks. This here is rubbish. Yeah, that's garbage. It tells us nothing. Tells us so little. All it tells us is the simple whole number ratio of atoms of each element in a compound. It doesn't tell us very much. Yet you cannot draw that. But we get that. So people often say, where does it come from? Why do we bother then? The reason being is the machines spit that out. That there is a result of mass spectrometry data. Result of mass spectrometer data. So you put in a sample and it'll spit out the empirical. And then you take the empirical and you weigh the empirical for its MR and you see how it relates to. So you can work out the MR of this guy, the MR of the empirical, which is 12 plus 12 plus 12 plus 6 plus 30 plus 35.5 plus 35.5. That's 77.5. And then you say, oh, well, hang on a minute. What was the actual thing? So we're told that the MR is actually 155. So what you do is to double it. Yeah, so you just double all the small numbers. Yeah, so we do this a lot. This is where calculations links into organics. But Tiff, you're absolutely right. The molecular is not that useful either because it doesn't tell us the position of the chlorine atoms. Yeah, this is where displayed and structural are so much better. Yeah, we can do a little bit of displayed. I'll draw one for you if you like. I gave you that formula. Oh, let's make it really challenging. Let's see how many people can do this. Oh, you're not going to like this. You're going to hate me. Okay, let's do that. Name that for me. Okay, I'll be nice to you guys. You don't know priorities. Even the chlorine would take priority, but I'll do this and this. That's better. Name that for me. Oh, impress me, year 11s. Let's see how good you guys are. Go on then. Impress me. Name that. If you can name that, you're working at an A-level standard. If I'm also going to give, so this one is A-level, not GCSE. I can give you a GCSE one. GCSE. Let's give you a GCSE version. Let's give you a GCSE version. Technically, that's actually not actually GCSE. It's slightly beyond GCSE because you're not expected to be able to name the halos. Yeah, but that's a lot easier. So there's an A-level one, a true A-level one, and then a GCSE one. So, by the way, it's actually AS. If you want to know the actual level, this is AS level. Oh, look at Tiff and Halping and Lara. Well done. Look, isn't it lovely the fact that, look, they've all got the same name? Isn't it beautiful? I love that. Tiff forgot her dash between the 1 and the D. And the 2 and the D as well. Well done, Amani. There's two of them, which means if it's a die, you have to have 2 numbers. That's actually AS level if you're interested. AS level. Well done. Super impressed. Oof, almost. Absolutely, almost. It's a good one. I'm impressed. So longest chain. This is how I build this. Longest chain first. Don't like the fact that I've gone over to the CL. Don't like that. Oh, delete that one. Put that back. There we go. Longest chain. So it is based on bute. It is an ane. So it's based on butane. My attachments, I've got a dichloro. So underneath this, I'm going to do this in purple. Yeah. This is a 1,1-dichloro. Yeah. I'm just going to move this guy. Move him down. Look. Pick you back up. There you go. And then I've got another attachment. I've got 2 more attachments here and here. Made that a bit thicker. Which is a 2, nope, too thick. A 2,2-dimethyl. And then I put them in alphabetical order, MC. So the C goes first. So 1,1-dichloro, dash 2,2-dimethyl. I'm running out of space. Moving over. There we go. Better. A bit more space. 2,2-dimethyl butane. We're done. Nice. Fun game or what? It's just a game, guys. As I said, that's AS. This one, much more straightforward. 1,1-dichloro. Dichlorohexane. Nice and easy. Much more straightforward. Hexane. Oh, here we go. Cool. Okay, so it's just nice to show you kind of these things that come up a lot. Okay, so fractional distillation. I want to get into fractional distillation now. So fractional distillation. So the first thing I need to get you guys to realize is this isn't just specific fractional distillation. This isn't specifically for crude oil. Fractional distillation is a method of separation, used on mixtures of liquids. Yeah. So if you wanted, so example, yeah, water and ethanol mix. Yeah, we'd want to use fractional distillation. Frac dis all day long. But if you had salt, nope, don't like it. If you had sodium chloride and water, you're not going to use fractional distillation. You'd use simple distillation is what you'd actually use if you want the water. By the way, if you want, I'll put simple distillation. I'll actually write that because if you're not listening, simple distillation. And that will collect the water. Yeah. Result in water collection. Yeah. If you wanted the salt, so this is to underline the salt is what's wanted. If you did sodium chloride and water mix and you wanted the salt, yeah, you're going to use Edexcel's crystallization. Yeah, so you would evaporate the mixture till 80% of the water is gone and then leave it in a warm place for the crystals to form and for it to cool down and crystals to form, and then you'd filter out the crystals at the end of it. Yeah, you'd actually end up with hydrated crystals at that point. But not that it really matters in this case. I'm not focusing on crystallization and separation of that method. I'm focusing on fractional dis. So why is fractional distillation used for mixtures of liquids? The reason being is because they have similar boiling points. We know that water has a boiling point of 100 degrees Celsius, BPT. Ethanol has a boiling point of 78 degrees Celsius. Yeah, they're only 22 degrees apart. Well, what that means is, if you're not careful, you're just going to end up with when you heat this, the ethanol will come out first because it'll boil first at the lower temperature. Yeah, you'll first get ethanol, but if you don't use fraction, if you just use simple distillation, you're just going to end up with a slightly better mixture, a higher percent. If you use simple, then you end up with ethanol water mix, but a percentage of about 80-20. If you use fractional distillation, you're going to end up with 98-2, much better separation method. Right, so let's now run it for crude oil. So let's do frac dis on crude oil. Now, this is actually a bit more complicated, crude oil. So just to let you know that there is the industrial version and the lab version, and you do need to know the difference between the two of them, but they kind of do the same thing, but there are similarities and also some differences. So what I'm going to do is I'm going to focus on the industrial first. Yeah, industrial frac dis. Okay, so in industrial fractional distillation, I want to now link this to a question. So I just jumped onto savemyexams.com. I actually typed in Edexcel iGCSE chemistry questions and Save My Exams came up, and I just clicked on look. This is this website. Oh, darn it. Our membership has expired, so I don't have the mark scheme. Not that I need it, but still, it's always good to have it. Still not there. Amazing. There we go. So this is what I Googled, and then it came up with this, and then I went down to organics, and I've just done crude oil C1. That's all I've done. You can see that there, crude oil paper 1. And so this is the fractional distillation tower. So you guys need to know this picture, and you can clearly see that they've actually got lesser fractions than I've taught you. There's only 6 fractions in this particular diagram. There are actually more like 7 or 8. And they're going to ask you to name a couple of them. It's very common. But this is the industrial one. Yeah, and you need to know these fractions in order in the tower because they're going to leave a couple off. And then, look, let's see if we can find another one. It's always good to do that, isn't it? To find another version of the same question. There you go. And they've labeled them A to F, and they're going to ask you probably, yeah, they're going to ask probably, oh, name this method of separation. And they might even ask you to name one of the molecules, one of the fractions in it. Let's see. Oh, there's the non-industrial version. There's the lab separation. And actually, that's a good method, so I'm going to steal that one in a bit. Same picture again, and this time they're asking about step A, which is cool. What happens in A? So, and then what is meant by the term hydrocarbon? You can see we've already done that. Look, compare the hydrocarbons D and F. We could also do naming them as well. So it's probably worthwhile stealing this image because it's actually really handy. I'm just going to pinch it. Hello, steal, yoink, edit, copy onto my document here, right? So this is the industrial. Now, I need to teach you a method for this. It's not just the diagram. It's not, the diagram is not actually enough. So paste. See if it goes in. There we go. So this process, we need it in words. So the process. So step number 1, we are going to vaporize the crude oil. The crude oil. Now that there is happening in A. That is there is vape. We're going to vaporize the crude oil. By the way, what that actually means is that we're going from crude oil, thick, black, sticky liquid, mixture of many liquids, and we're turning every single one of them to gas. That's what vaporize means, to turn a liquid into a gas. Right, now I know this is weird. So there's step 1. Now step 2 is here. Step 2. I know it's odd, this. It seems very strange. But the point of this step is to explain that this is outside the tower. Yeah, so step 2, feed gas into tower. There we go. So we're going to feed it in step 2. Right. Step number 3, we need to tell them about the tower. So what's special about this tower? So this is number 3. This is S3. Yeah, and the tower is hot at the bottom and warm at the top. You're not allowed to say cold, be aware. Step 3, tower has a temperature gradient. Who calls that word? Gradient. That's French for gradient, by the way. Tower has a temperature gradient, hot bottom, and warm top. There we go. Hot bottom, warm top. Telling them it has a temperature gradient. I like to give that as actually only 1 mark. They will actually allow, I think, just temperature gradient, but I prefer to have the other one there actually in relation. So the next thing is, once we've now got it's hot, now I need to explain what's going to happen to the molecules. Yeah? So the molecules, as they go in, we realize crude oil is a mixture of short, going into skeletal now, if you guys remember this from my lessons. So there's butane. So there's a short one. Here's a long one. There we go. And then there's an even longer one. Crude oil goes from, yeah, so crude oil has a mixture of 1 carbon all the way up to 50. Very long. Yeah. And what's going to happen now is that bigger molecules have a higher boiling point. So number 4 is, now that we've told them what's happening with the gradient, we need to talk about the oil. So step 4, bigger molecules have higher boiling points. Have higher boiling points. Higher boiling points. Right, we now need to explain why that is. Yeah, and the reason why, step 5, bigger molecules have stronger, have stronger, bear in mind, this is a comparison, stronger WIMPs, weak intermolecular forces. Now, by the way, this one here is the most problematic one of the whole shebang. This one here causes me trouble every single year. Because, guys, if you wrote down this, if you got rid of that and just wrote down strong, yeah, you lose that mark. The reason being is you can't have strong, weak intermolecular forces. You can't have strong and weak next to each other. But what you can say is stronger weak intermolecular forces. And bigger molecules do indeed have stronger weak intermolecular forces. Let's show you why. So here's butane. Here's butane. I'm not going to bother showing my hydrogens. Can't be bothered. Yeah, and here's another butane. Yeah, I should have just written butane. I'm an idiot. 4 carbons, and these are the WIMPs between them. Now you can see that there are 3 in this particular diagram. Yeah, these here are WIMPs. You know, you can't write down WIMPs in your exam. You've got to translate it in your writing, weak intermolecular forces. Yeah, so here's decane. Yeah, so decane is much larger, 10 carbons. Yeah, 10 carbons. Have I gone more? I think I've actually added, there's 11, dodecane, undecane actually. And then you've got another one underneath it of another 10. And what you realize is that there's going to be stronger intermolecular forces. Yeah, there we go. The intermolecular forces are going to be stronger. So these are also WIMPs, but because it's bigger, they're stronger. I wouldn't say that there's more of them because it's not entirely correct. You can't really quantify them in terms of numbers, but you can quantify them in terms of strength. So they have stronger weak intermolecular forces. Now what this means is, this now tells us, I'm just going to swing that diagram, I'm going to delete it. Why would it, why? Just got to make sure that you actually cover everything. Just move that over to there, there we go. So these are stronger WIMPs. Right, now since that's the case, bullet point number 6, yeah, step 6, bigger molecules. So the last ones are about the molecules. First 3 are about the tower, second 3 are about the molecules. Bigger molecules have a higher boiling point, So condense lower in the tower. So the larger molecules appear at the bottom. That brings us to the end of our 6-point step. Yeah, and they may only be 4 marks, but you've got to give the whole lot for all 4. I'll show you that now. Look at this exam question. Yeah, so what happens vaporizing of crude oil? What is meant by the term hydrocarbon? A compound made of hydrogen and carbon only. Carbon atoms only. Compare the boiling points of D and F in terms of boiling point size of molecules and viscosity. Compare the hydrocarbons. Right. So that's nice that it's linked viscosity in there as well. So where's D and F? So D and F. So F is smaller than D. So we'd say that F is small. It has a smaller molecule size than D. 1 mark. The boiling point of D is therefore higher than F, and the viscosity of D is also higher than F as well. Done. Nice and easy. 3 bullet points. Moving on. I just want to show you the question of the fractional distillation, where they actually ask you, there we go. Explain why cracking. Nope, it's not the right one. There you go. Describe how crude oil is separated in fractions in industry. So you just now regurgitate those 6 bullet points into that place. Yeah. Cool. I like it. Okay, so we've covered fractis, which is quite nice. Nice to also do our fractions. Yeah, natural gas is G, nat gas. Then it goes to petrol, then naphtha, then kerosene, jet fuel, then diesel. Now that's actually interesting, isn't it? Because in reality, that's not correct. Because it's missing one. It is diesel next. That's what I would do. There should be another fraction coming out here, which is fuel oil or lubricating oil, either one. It actually goes lubricating oil and fuel oil, actually, just so you know. Fuel oil, and the last one being bitumen. So natural gas is a fuel. Petrol is a fuel for cars. Naphtha is used in the petrochemical industry. Kerosene is jet fuel. Diesel is car fuel. Fuel oil is for tanker ships. And bitumen is used for road surfaces. You've got to know those uses, really important. Okie dokie. Next, drawing some isomers. Yeah, I think this is very reasonable. Just want to show you again, you know, that these questions are very common in organics, and there it is. I'd like you guys to have a go at this question. Please pause the video and have a go for me. Pause the video. I'm just going to screen snip it, and then I'll do my answer. So it's given you C5H12. It'd be nice also, anybody on the chat, please, if you want to try and name that. It again is it is AS level. That's an AS name. But this is a GCSE question. They're not asking you to name it. What they're asking you to do is draw other isomers. Yeah, so if somebody wants to just post on the chat the name of that compound, that would be amazing. And if you listen to the previous one, if you look at the previous ones, you'll see a part of that which might be helpful. So draw two other isomers of C5H12. So the first thing I want to realize is that molecule there, first thing to realize that it has a general formula. Yeah, let's shrink this. This is CnH2n plus 2. This is called a general formula. Let's put general form. Yeah, and this is the general formula 2,2-dimethyl propane. Well done, Halping. Well done, Lara. Good job. So this is the general formula, CnH2n plus 2. That's because the 5 was doubled to make 10, and then we add 2 on to give 12. Yeah? So this is the general formula for an alkane. So that is an alkane. So what we're now going to do is, now it's given us a branch. This is called a branched. I made a mess of that. This is called a branched alkane. Branched alkane. And the first thing I'm going to do is I'm going to straighten it out. Let's make it easy for myself. First isomer I'm going to draw. Usually they give you the straight one and then ask you to draw a branched one. Yeah, I'm just going to straighten this out. It's got 5 carbons in it. Yeah, and then just cover it all in hydrogens. Now, what I'm then going to do is I'm now going to give it 1 branch instead of 2. So recognizing that this is a dimethyl is kind of useful. I'm just going to give it 1 branch. So I'm going to make a chain of 4 and put the carbon there in the middle. You can't put the carbon on the end. That is the same thing. Yeah, that's just bent. Yeah, you've got to put it on a carbon in the middle. And then you add all your sticks. Count them up. Yeah, make sure everybody adds up to 4. Yeah, so that is pentane and methyl butane. If you want 2-methyl butane, that's absolutely fine. But there are the 2 isomers. Really nice. You can't move it to the next one. If you move this now to here, if you move that up to this point, that's actually still the same thing. Yeah, you're just reading it from the other direction. Just bear that in mind. Just nice to realize that. It's a very common mistake that students just draw the mirror image. Well, that's just the same thing. So isomers are relatively straightforward in terms of the questions. Yeah, you just have to adapt depending on the one that they give you. So we can do a few more of those, just because they can be quite a lot of fun. Let's have a go at doing another one. Let me give you C4H8. Now, all of a sudden, this is a molecular formula. This is molecular. I can get you guys to do several things. I can say convert it to empirical. Yeah, I can get you to do that. I could get you to convert it to displayed as well. Yeah, displayed formulae. Displayed form, question mark. Yeah, but then this one, of course, is going to have isomers. Yeah, you're going to have different versions of it. The next thing is to recognize that the general formula here, the general formula for this guy, you can convert it up there as well. General form. Yeah, you can actually do all of these conversions now. So pause the video and have a go at doing them. It's really good practice. Okay, so first one, empirical. Simplify it, find the smallest number and divide it by that. Divide everybody by that. So that's just going to be CH2, empirical. Take it if you got it. General formula. Right, so this one's a bit more tricky. It's just Cn. So we're turning that the smallest number then into the n value. And this one is just simply to double it. This is H2n. There we go. This is the general formula for an alkene. So this is now an alkene and not an alkane. It could be cyclo though. So that's something to bear in mind. Yeah. So displayed, what one's going to have? The first one I would always draw is the straight version. 4 carbons in a row. But now I've got to add a double bond and count my sticks. It's a very, very, very common mistake, guys, for students to add too many hydrogens. Please be careful. Students like to do this. Please don't. They are not there. Otherwise, the carbon has too many bonds. There's also too many H's to match the formula as well, right? So there's one of the isomers. I'm just going to create the straight one. The next one is I'm going to move the double bond. So by the way, that's but1ene because the double bond is between carbons 1 and 2. I'm going to count from that direction. Yeah, and then I'm just going to move it and put the double bond in the middle. There's another one. So this is but2ene. This is but2ene. I'm impressed if Haoping knows that there's another version of that one as well. Don't worry, you don't need to know that. That's part of, again, it's A-level chemistry. It's just nice to mention it to Haoping. So can I move it another one? Can I move it right over? The answer is no. The reason being is this one here is the same as this one. I'm just going to count from the other direction. Yeah, so they're the same thing, so that doesn't count. But could I branch it? I think I can branch this. Let's give the double bond there and put a branch on it. So the first step I did was to move it, move the double bond. The second one is to branch it. So that one works as well. There's also one more as well, of course. There's actually two more, annoyingly. Yeah, you could have also done this. Could have also been cyclobutane as well. And then I could also have another cyclo as well, another cyclo of methyl cyclopropane as well. That one also adds up as well, I believe. There we go. Oh, well done, Haoping, knowing his E and Z. Well done. This is, yeah, this one's a Z. This is A-level. And there is another isomer of E. You don't need to know this, folks. I'm just doing this for fun. Yeah, that double bond being in the middle means that you can now get what's called geometrical isomerism. This is part of AS Unit 1, and the hydrogens are on opposite sides. So this one, so if you were going to name them, this one is Z-but2ene. But2ene, and this is E-but2ene. It actually goes in a bracket rather than a dash, if I'm honest. E-but2ene. The Z is the hydrogens there are on the same side. I'll stop now. Anyway, loads of isomers, lots of fun games to play with this. I would not recommend doing these ones in your, Mr. Duncan, this is kind of hard, I'm suffering. No, it's not, Atia. They're not, the questions, I'm teaching you, Atia, at a level that's a really good level because it makes the questions in the exam very easy. I just want to show you that there are options here. I'm not expecting you guys to be able to draw lots of these things. You realize that the key thing is, can you branch it? Can you draw a straight chain? And alkenes can be cyclones. That's really all you need to take away from that. Yeah, so if you want to do some kind of summary, nota bene, summary, iGCSE isomers. Yeah, number 1, branch it. Number 2, move it. Move it should really go before branch it, but it doesn't really matter. Number 3, enes and cyclos. Yeah, that's all you really need to know. That's it. That's all you need, Atia. Yeah, so a straight chain, so the example of these, yeah, the straight chain, if you had 4 carbons in a row, you could branch it. Yeah, you could move one of the carbons into the middle. Move it. If you've got a carbon, a chain that has a chlorine on it, you can move it. Yeah, I can move that. I can move that to carbon number 1. I can't move it in the other direction because that would be the same thing. Yeah, but I can move on to carbon number 1, so move it. Could do another version of that as well with the double bond. So if I had but1ene, got to do my sticks now for that one, it's important. But1ene, I could also move it. Yeah, move it to the second one. You don't need to overthink this, Atia. It's really not that complicated. It's almost Ken Bop it. That's funny. And then enes and cyclos, just remember that if someone gives you an alkene, something like propene, what you can always do is put it in a circle. Yeah, put it in a circle. And it's no longer an ene. So this is propene, and this is cyclopropane. Now, you do need to know, since we're on that one, since we're here, so these have the same formula, same molecular formula, C5h12. So if I had 2 test tubes, if I had 2 test tubes of these things, there you go, and one of them was an ene, and one of them is a cycloane, yeah, a cycloane, I can do a very simple chemical test. What I'm going to do is I'm going to add to both of them, add orange bromine water, Br2 aqueous. It's going to add bromine water, and it's orange. And what will happen is, so bromine water goes in, and what will happen is the alkene will decolorize it. Decolorize, turn it colorless. Decolorize. But the alkane will do no change. Just remains orange. Yeah, you need to know that one, guys. Chemical test for alkanes and alkenes. Yeah, bromine water. I'll write that underneath, bromine water. Bromine water. It's French for water. Okay. Just want to have a quick look back over my, look back at the questions. I got to the end of that document, I think. Oh no, there's a calculation that runs at the end, empirical molecular, very common. Yeah, it's a very good question. That works really well. The next thing, of course, next lesson we'll have a look at pollution again, and do a bit more on pollution. But just some nice other questions to show. Explain why decane is described as a hydrocarbon. It's made of only carbon and hydrogen atoms only. Give the molecular formula, C10H, double it and add 2. Yeah, it's quite nice. Oh, I like this one. So they've said molecular formula, and they want you to complete all the boxes. Isn't that fascinating? They're all slightly wrong. I quite like that one. That's really pretty. Full screen snip. I like that one. Good question. So this one is rather lovely. So I got to put a C there. Oh, actually, hang on a sec. It doesn't, hang on. I say that. Yeah, of course it is. It's the only thing I can get there. Lol. That's funny. Yeah, so C3, there you go. Right. Yeah, see, so that one is already correct and done. That's quite nice. But then what is that? That there is the general formula. It says the word up there, so I don't need to write it. It's good. This one, that's the empirical. They've simplified it. Empirical. And then they want me to draw the display of this. So then you have to realize it's an alkene. So I'm just going to make it straight. Make it straight. Propene. Just make sure you count your sticks. Yeah. Everyone knows that the most common mistake in these pictures is that students will do this. We know they're going to do this. We know they are. They'll add the double bond, but then they forget to count. You can't do that. That carbon here, this carbon here now has 5 bonds. 1, 2, 3, 4, 5. It doesn't add up. You can't do it. Take a H away. This carbon here, change my color. This carbon here has 5 bonds. Yeah, change my color. Yeah, 1, 2, 3, 4, 5. Too many. Get rid of 1. Yeah, there's propene. And it's totally fine to draw it straight. Absolutely fine. Look, nice question that though. Give the name of this. Oh, propene. Nice and easy. Deduce the molecular formula. Oh, they're doing cracking now. Now, cracking isn't actually on your test, I believe. So I don't need to worry about cracking today, which is nice. Nice to mention viscosity and other properties. I'll do that next lesson. Properties of hydrocarbons of different lengths. We'll look at that next lesson. Oh, it's nice just to mention, this one's quite a nice, because it's given the lab version. So in the lab version, we can't vaporize all the crude oil. We can't do that. So what we do is we just boil the mixture, and each gas will leave in successive order. So this is the non-industrial version. This is lab practice. So just to finish my lesson, lab practice. What I'll do is I'll take a boiling tube with a sidearm. Yeah, boiling tube with a sidearm. And I will add my crude oil. Step 1, add crude oil to boiling tube with a sidearm. Yeah, so this is now my crude oil. Looks like crude oil. Crude oil. Right, now what I'm going to do is I'm going to add a cork at the top with a thermometer. Yeah, and that thermometer, by the way, should actually be at the leaving junction. Should be just there. Add a cork, there we go, with a thermometer. Then what I'm going to do is I'm now going to hook up a delivery tube. That, by the way, should actually be a condenser. That should actually run into a condenser. Yeah. Yeah, this piece of equipment here is called a condenser. That there is a condenser. What that's going to do is, because we're going to heat this, yeah, and let's say we've got a mixture. Let's say our crude oil here, just our sample. Let's say it has 4 different liquids. Let's say it has hexane boiling point 60 degrees. Yeah, easy number to remember that one because it works kind of well because it's a 6. And then let's say we've got petrol octane, which we know is 20. Sorry, is 80 degrees, 80 to 90, 80 degrees Celsius. Now, this is where this is simple distillation. This is not going to do a good separation. It's going to be incredibly poor. That's because the boiling points are similar. There's going to be overlap. Yeah, let's say we then go to dodecane, which is 12 carbons. That's about 120. And then let's go to hexadecane, which is 16 carbons, and that's at about 160. So what we now do is we heat this. Now, the first one that's going to leave is going to be hexane. It's going to go first. It's going to boil off. Yeah, the first one that's going to go is going to be the lowest boiling point. Yeah, the next one that comes off is octane. Obviously, it's going to be second because it has the next highest. Then it's going to come off as decane, and then it's going to come off at dodecane, fourth. And we're going to have to really heat this. And it's nice to see what this question does, because what they've done is they've just given you the steps and then asked you to put them in order. And they've given you use the second one, fit a thermometer in the boiling tube. So what must have come first? Pour crude oil into the boiling tube. There you go. S is going to be first in there. So SU. And then what's next? Pour crude oil into the boiling tube, fit a thermometer, connected delivery tube. Yeah, there you go. So now we've got to R it. So SUR. Yeah, connected delivery tube. And then we're going to heat the crude oil gently at first and then more strongly and collect each fraction in a different test tube. So we're just going to then switch the test tube around. It's a terrible condenser, this little black object in the middle. I should probably screen snip that just so I can draw on it a bit, just to show you the final outcome of that. Yeah, so S was first. So pour in the crude oil. Next, fit the thermometer. Connect the delivery tube. Yeah, then we're going to heat the mixture gently at first and then more strongly, and then finally collect each one of them. Serve it. I like it. And that's just a clamp stand. It's just a delivery tube. The improvement to this would be to use a condenser, and we just get a better separation. Also a fractionating tower. Yeah, just nice just for me to end on a fractionating tower, just to show you both pictures exist. Fractionating tower. I don't know if that's actually come off. There we go, images. Because in the lab, we have this rather weird setup. There you go. So there you can see the condenser and the fractionating tower. Is it going to let me zoom in? There we go. So you can clearly see the fractionating tower is this big, tall piece of glass with lots of levels. It just allows anything that boils that shouldn't be will condense in that tube first and return to the vessel. The smallest ones will reach the top and come out, and then you condense water in, water out. It's a good image to know that one. Right, guys, that brings me to the end of my lesson, which is nice. It's been fun. I'll bring it back to this one. I'll stop sharing. Guys, thank you so much. It's been great to see you guys. I hope you all had a really lovely Christmas and New Year. And I'm going to be seeing you guys in school on Wednesday, which would be amazing. And then you guys get an opportunity then to ask me as many questions as you like. And we'll continue with doing some organic revision for your mock exam. Take care, guys. Have a good rest of your day. Enjoy your lunch. Bye now.